So, welcome back. Now, in this video lecture, we will see the basic electrical elements. So, even though I have named this one as network elements, I'll stick to only the basic three elements of R, L, and C. We call them as R, L, and C. You might be knowing this. R stands for resistor, L stands for inductor, and C stands for capacitor. So, we will discuss about these three things now. So, when I'm here to discuss these network elements, before I start this one, I would like to say you one thing, that all these three network elements, they offer opposition to the flow of current. As already I told you, current is nothing but the flow of electrons in the medium, right? So, can the current freely flow in all the materials? No. It differs from one material to another material, right? And the opposition which is offered to this current, we call it as resistance. This is the common word which we use to the property of an element which opposes the flow of current. Some elements, they do offer direct opposition, whereas some elements, they do offer opposition to changes in currents. Rather than opposing the current, they will just oppose changes in currents. So, in this lecture, we will see what are the properties of different elements, particularly R, L, and C, and how they do oppose the flow of current. The first one among these is the resistor. And you know that a resistance is a property of an element by virtue of which it opposes the current. So, no matter whatever the element is, resistance means it opposes the flow of current. So a material is having this much amount of resistance, which means that it is capable of opposing the flow of current. Normally it is represented by R and it is measured in ohms. This is the symbol of ohms. And the representation of resistor is this one. This is the representation of resistor. And the governing equation of voltage and current in a resistor is V is proportional to R. So how much current flows in a resistor? The same amount of voltage drop will be developed across it. So V is equal to IR. This is the proportionality constant. So if I allow a current to pass through the resistor, then automatically there will be a voltage drop across this. This is what we call it as resistor. Now, moving ahead, inductor. It is often represented as in this fashion. So this is resistor, right? This is inductor. It is just like a coil. So whenever a current is passing through it, it develops an EMF across it. Inductance is the property of this element by virtue of which it opposes change in current, not directly current. It opposes change in current. So when the current is not changing, then the magnitude of current is not changing. Then automatically it won't offer any opposition to the current. But when the magnitude of current is changing, then only it will offer opposition. Think one second. If di is equal to 0, there is no change in current. Opposition offered is 0, which means it acts as short circuit. But whereas, when there is a change in current, then automatically the opposition will be varying and it depends upon your di by dt. So this is a unique property. And this property we call it as inductance. And inductance of any element is represented by L and is measured in henries. H. So And in the process of opposing the change in current, it develops an EMF which is proportional to the change in current. Right. So if I remove the proportionality constant, E is equal to L di by dt. EMF is also a voltage, so I'll write it as V is equal to L di by dt. Okay. The next one is a capacitor. Your resistor opposes the flow of current. Your inductor opposes change in current. But whereas a capacitor, it opposes change in potential across it. And it is represented as this one. So one is a straight line, the other one is a little bit curved one. And some textbooks they will use both equal, but normally this is the representation. One curved, one straight. So it opposes the change in potential across it. So normally represented by the symbol C and measured in farads. There. And in the process of opposing the potential, when dV is 0, then it will act as open circuit. Sorry, I is equal to 0, so it acts as open circuit. When dV is present, then automatically I will be present. And this I is proportional to dV by dt. If I remove this one, you can write it as dV by dt. And if I write, this is the relation between V and I in capacitors. Now, if I bring these properties together, this is an important table which you must learn. So, as of now, we have come across C. Coming to the function, resistor opposes current, inductor opposes change in current, whereas capacitor opposes change in potential drop across it. And the representation, it is R, this is L, and this is C. And the symbol. Right. And units, resistor is measured in ohms, inductor in Henry, this is ohm symbol. This is H and this is farad. Now VI equation, V is proportional to I, so V is equal to IR. Here V is proportional to di by dt, so V is equal to L di by dt. I is proportional to dV by dt, I is equal to C dV by dt, or I can write, right. And coming to power. In resistor, active power is consumed and the energy is dissipated in the form of heat. This is an important thing which you must remember. In resistor, power is dissipated in the form of heat, whereas these other two elements, they store energy in the form of some magnetic or electric field. Inductor stores energy in the form of magnetic fields, and in capacitor, energy is stored in the form of electric fields. And coming to powers, in resistor we do have active power, whereas in inductor and capacitor we do have reactive power. And coming to impedance, we will discuss these things in unit number 3. And I hope that now you are able to define the different electrical terms, and I hope that now you are able to compare the properties of resistor, inductor, and also capacitor. So we'll meet again.